Welcome to this tech tip showing how to add cutting technology to EdgeCam's ToolStore database. EdgeCam's ToolStore provides a central database to store and organize tooling, cutting technology, and to capture programming data for setup reports. This video will show how to add cutting data using the Technology Assistant. You can easily add materials and cutting tool grades, and then assign cutting data so that feeds and speeds can be automatically calculated. This data entry can be done quickly and enables EdgeCam to simplify toolpath creation by looking up your cutting feed rates and spindle speeds. We'll start by opening the Technology Assistant, located in the EdgeCam Program Group's ToolStore folder. I'm using the sample database that is installed with EdgeCam. This database already has cutting data lookup. It's a great place to begin if you're just getting started. Notice that materials are displayed on the left. These would be the materials that your company frequently machines, and you can assign any name that you wish to each material you require. Existing materials can be edited, and new material records can be added. We'll create a material record for Inconel. The description is the only field that requires a value. There are many other fields available that can be used for whatever organization you find helpful. We'll add a few pieces of data. We'll add some information into Family that will create a new tab to organize this material, and then we'll also set the SAE standard as well as material groups for several different tool manufacturers. After clicking OK, the material is now created. The cutting tool grades, called inserts, are displayed on the right. Each tooling grade can be linked to multiple material records, so a user with a wide selection of milling, drilling, and turning tools has a great deal of flexibility to create the inserts that best organize their cutting data lookup. We'll add a tooling grade for drilling tools. The insert grade's a Sandvik Coromant GC1220 and will be used for drill applications with Cora Drill Delta C tools. The solid tool category should be used for non-indexable insert mill tools. After selecting the appropriate category and adding some additional qualifying data and selecting OK, the insert record's created. Next, we'll enter the cutting data lookup. This is a simple process of selecting the insert grade and the materials to link it to. Now I can add cutting technology, and the cutting data can be entered and can be applied to all the materials in a single action. I'm going to use the manufacturer's data to enter suitable values. Because this is a solid tool category, I can set different diameter ranges for things to apply to. To enter a new diameter range, I simply click the right arrow and then enter the next range size. The first range was up to 1/4 inch, the second range is from 1/4 inch to 1/2 inch, and then we'll enter a third range from 1/2 inch to 3/4 of an inch. Notice that the speed values are input in the feet per minute that the manufacturer provides, and the feed rates are inch per tooth values. That will look up the appropriate RPM and inch per minute cutting values that would be typically used and output in milling programs. I'll simply tell EdgeCam to apply all of these data to the materials, so all the materials get the same data entered in one shot. Once you've input the values and pressed OK, the changes are made. All of the linked materials have lookup data. Now realistically, we may want to adjust that for different materials, and you can easily edit data after the fact, just like I've done here by editing the insert. In this case, I'll enter unique data for the aluminum material. Notice that the size ranges are already set up. All that I have to do is change the value within the size range. Now once you've entered values, the changes are done immediately and are available for tool lookup within EdgeCam. We'll explore how to use these values in a separate tech tip video, Technology Assistant Part 2. In the meantime, you can get started entering the materials, tooling grades, and cutting lookup values for the common tools you use. You may also want to check out the 3 tutorials available in EdgeCam's help menu that cover Technology Assistant. EdgeCam's ToolStore provides a central database to store and organize tooling, cutting technology, and capture programming data for use in setup reports. The previous video segment showed how to add materials and cutting tool grades to the database, and how to create the cutting data relationships. Once that initial data is created, it is easily linked to tools and used for everyday toolpath creation. This video segment will show how to leverage existing cutting data for automatic assignment of feed rates and spindle speeds during EdgeCam use. This allows you to use EdgeCam more efficiently, offers standardization with both single and multi-user environments, and enables excellent utilization of knowledge-based machining. We'll start by opening the tool store, where automatic cutting data lookup is made possible by linking tools to existing cutting data. Let's edit the 1/4-inch drill. Sandvik refers to this as a 6.35 millimeter Coro drill. So the tool description used in this database is intentionally designed to relate to the specific tool. Notice that the GC1220 tool grade has been added to the end of that description to assist with identifying tool into the EdgeCam user. The Technology page tab of the tool record is where cutting data is added. If your company only machines a single material, it's possible to enter the appropriate feed rate and spindle speed values. In this case, the GC1220 tooling grade for this tool can machine a wide variety of materials, so it's preferable to link to an existing record. Once that relationship's established, notice that the tool now inherits the cutting data lookup for all materials that the insert's linked with. If we update the Technology Assistant data in the future, the lookup data for all tool records linked with the insert will automatically inherit the cutting data. Now that the cutting data is entered and lookup is possible, let's use the data to simplify EdgeCam toolpath creation. First, we need to tell EdgeCam which material will be used for the current part. Using the Select Technology command, located in the Options menu, we'll browse and specify the material from the database. We've chosen Inconel for this part. Now, when we select tools, database filtering can easily help select tools that are qualified to cut this material. Next, we'll use the machining strategies to quickly build tool path for the 3/16 holes. This useful tool path accelerator will select a 4.8 millimeter Coro drill with the GC1220 tooling grade, and it also creates a suitable hole drilling cycle that has the correct feed and speed values. The tool is selected based on ability to machine Inconel. If we edit the tool, notice that the tool store filter looks for tools based on having cutting data lookup for the material specified in the model. When we edit the tool and view the information on the Tools Technology page, you can see the surface foot and chip load values assigned in the Technology Assistant, and also the resulting RPM and units per minute values that will be output in the CNC code. Back in EdgeCam, notice that the hole cycle has the appropriate cutting data. The machining strategy has assigned the proper speed and feed values to the hole drilling cycle. Of course, the EdgeCam user is in control. You can alter the actual data if you wish. I'll demonstrate that by reducing the speed and feed values from the cutting data lookup. It's also possible to easily revert back to using lookup data. I'll edit the whole cycle again and select the finishing technology. Notice that the lookup data values are restored. If I leave the finishing technology selected, this tool path cycle will always use the lookup data for the current tool. If we select a different tool in the future, or update the Technology Assistant data, the whole cycle will be automatically updated to use the current data. If you wish to simply use the data without enforcing automatic future lookup, as I do here, then simply change technology to none. One final note is that there may be situations where the cutting data recommended by the database lookup exceeds the CNC machine's capabilities. The Apply Speed Capping option in the machining sequence will reduce cutting data to exactly what the machine capabilities are. This guards against users entering excessive spindle speeds and automatic calculated speeds that are excessive. If speed capping is active and automatically modifies an existing spindle speed value, the feed rate is also reduced to a corresponding value in order to maintain the proper chip load per tooth. This is very helpful. The maximum spindle speed values used for speed capping are assigned in the CodeWizard post. They can also be modified for a specific tool using the spindle page. Notice that you can set the gear range and the maximum spindle speed values. Please note that this capability requires a post processor created using adaptive lathe and mill templates.